Hi class, in today's video we're going to talk about restrictions. We've been looking at rational expressions and how do we simplify those rational expressions, but a lot of questions that have been coming up in class is how do you state the restrictions? So let's do that. So let's say that we have a rational expression. We'll start with a very basic one of just 1 over x. Right, so let's just say we're looking at 1 over x. A restriction is caused by whenever we divide by 0, right? So if we don't want to divide by 0 over here, then that means that x cannot equal 0, right? Because if x equaled 0, we'd have 1 over 0, and that just can't happen. So since x can't be 0, we would just state it. It's kind of like a little equal sign with a line through it, which means it cannot equal 0. Okay, so let's look at some more examples. So let's say we had 1 over x times x plus 1. Well, now I need to look at two cases that might make all of this equal to 0. So the first case is the same as before. X cannot equal 0, right? Because if I plugged a 0 in here, I'd have 1 times 0 times x plus 1, and all of that would just be 1 over 0. So that can't happen, right? And then my other restriction is caused by this bracket over here. So this one is x can't equal negative 1. Because if x equaled negative 1, I'd have 1 over negative 1, or sorry, this one was a 0, times negative 1 plus 1, and that would equal 1 over negative 1 times 0, and that can't happen. So one kind of quick way to figure out if we have the right restriction or not is we can take the terms that are in our denominator over here, and we can set them equal to 0. So the first one was x equals 0 over here, and then our second one is x plus 1 equals 0, and then we solve for x. The first one's already solved, so this one goes here, and the second one, we just bring the 1 over to the other side, and this one becomes our second restriction. Let's look at another example. Let's say I have 1 over a times a plus 1 times 2a minus 4. Right? Well, now I'm not dealing with x's anymore. I'm dealing with a's, but I do the same thing. I look at all of my bottom terms, all of my bottom binomials in this case, and I try to find the values of a that will make all of this equal 0. So my first one is just a equals 0. My second one is a plus 1 equals 0. And my third one is 2a minus 4 equals 0. So what I do is I solve for a. The first one's already solved. The second one, I have a equals negative 1. And this third one, I bring the 4 over to the other side. I divide both sides by 2. And I have my third restriction. So when I'm stating my restrictions, I have a cannot equal, not equal 0, negative 1, or 2. And it doesn't really matter what order I put these in, but sometimes I like to order them as well. So I'll have negative 1 first, then 0, then 2. Just to communicate the idea of the restrictions in a slightly more orderly manner. Okay, let's look at some more examples of rational expressions. So let's say we have a rational expression that is x plus 1 times x plus 2, all divided by x plus 2 times x plus 3. Well, we know from our previous examples, right, that the bottom part is going to equal 0 when x is -2 or -3, right? So basically I took this one, I set it equal to 0 and solved for x. So that's where my first restriction came from over here. And then I set this one equal to 0 and solved for x. And that's where my second restriction came from over here. Once I know what my restrictions are, you'll notice that there's a term on the top that is in common with a term on the bottom. I have x plus 2 in I have an x plus 2 on top and an x plus 2 on bottom. And we know that from rational expressions, if we have the same term on the top as on the bottom, they can cancel each other out. So my simplified version of this rational expression is x plus 1 over x plus 3, where I have the restrictions that x cannot equal -3 or -2. Now, note that even though I got rid of the x plus 2 on the bottom over here, it still is part of my restrictions. My restrictions are not just, they're not just the restrictions for the final statement. My restrictions are basically saying, when is my rational expression going to equal 0 at any stage of my my calculation, right? So since my original had an x plus 2 on the bottom here, that means that I have to include that into my restrictions as well. Also, I want you to notice that x plus 1 was not considered as one of our restrictions. The reason for that is because if x was equal to -1, right? So let's say x equaled -1. So my equation was x plus 1 times x plus 2 over x plus 2 times x plus 3, right? If x equals -1, then I have -1 plus 1 times -1 plus 2, all divided by -1 plus 2 times -1 plus 3. So that equals -1 plus 1 is 0. -1 plus 2 is 1, divided by 1. -1 plus 3 is 2. And this whole thing just equals 0. So you'll notice that I'm not dividing by 0 here. And that's why x can equal -1. If my expression just equals 0, then it's totally fine. But if x is on the bottom and those expressions equal 0, those are the ones I have to watch out for, right? So this is in the case, let x equal -1, right? But if if x is equal to one of my restrictions, so for example, -2, then this is what happens. I get -2 plus 1, -2 plus 2, -2 plus 2, and -2 plus 3. So I have a -2 plus 1, which is -1. I have 0 on the top, which is fine. I have 0 on the bottom, which is not fine. And then I have -2 plus 3, which is 1. So what I end up getting is 0 divided by 0. And it's fine that I have 0 on the top here, but since I'm dividing by 0, this is where my restriction is coming from. So this is what can't happen. Okay, so I hope this clarifies our understanding about restrictions. Please give the worksheet in class today a try, because we always need to practice this stuff, right? We might think we understand, but if you're not practicing, it doesn't stick in time for tests and that sort of thing. Okay, so good luck, and let me know if you have any questions. Thanks.